Welcome to the last video of our Verilog course, and in this video we will cover FSM, the last topic I want to cover in our Verilog course. After this you can write any code in Verilog and you can clear any interview in respect to our Verilog. Okay, so in FSM you have heard of two types, and one is Melee and another is Mure. So we are using Melee, and any of one you can know for writing a code. So we are using 101 as a sequence. Now X is our input, this 001 is Y is our output, and S0, S1 and S2 are our states. Okay, so we will detect this 101 as a sequence, and for example of your finite state machine, you can say vending machine is one of type of which use FSM, and any other like APB protocols also use FSM. Okay, so FSM is very important topic. Now let's say if our input is 1 first, so 1 is detected, you can say, so it will change its state to S0 to S1, which is it is changing, and if our input is our 0, then it will remain in the same state, okay, as 0 state. If our next input is 0, then it will change our state to S2. Okay, S1, if input is 0, then it will change our state to S2. Okay, if our input is 1, then our S1 state will go to our S0 state, reverse. Okay, and next if 1 is coming to S2, if input to S2 state is our 1, then it will detect 1 as output equal to 1, and our 101 sequence is detected. Okay, otherwise if our input is 0, then it will again go to our S0 state. Okay, this is a simple thing. Then you can understand this Melee and Mure concept theoretically more in digital part, but this is enough for writing a code. So let's start with writing our code. So let's start with module as always, FSM, and X, Y, reset, because we need something to reset all the things, and lastly we need our clock. Fine, and now input will be our Y and our clock, and our output range will be our Y. Now one thing we need for writing FSM is parameter. As you can see, we have written S0, which will be numbered as 00, S1 which is numbered as 01, and S2 is numbered as 11 or 10, whatever you want. So here comma and semicolon, so all the things is covered in our parameter. Now when again we need a state as a variable. Okay, and this is 2 bits, so we need 1:0. Okay, and next is your next state as a variable for range. These two things we need for writing our code. Now let's start with writing logic. So first is our always @ posage clock or posage. Here we have done asynchronous for reset. Okay, and the logic will begin from here, and if our reset is there, reset is 1, then our state is equal to non-blocking equal to our S0. Okay, else the state is non-blocking equal to next state, whatever the next state will be, and end. So this is our logic for reset. Now we will write logic for our FSM. So always @ and here we are using the star. Okay, Now we are using case. In case we are writing our state, because we are using state as a variable now, and so whatever state will be there, we will change that state. For first state S0 will be there, and we are writing if x is there, f x is 1. Okay, so remember our sequence. If x is 1, then it will go from S0 to, sorry, its next state will go from S0 to S1, and else, and you have to write here, one sec, begin. Okay, after begin you can write these all things. Else our next state means if 0 is there, our next state will be 0, the same state. Here y is equal to 0, because for now we haven't detected our sequence. Okay, now S1 begin. If x means our next input will be 1, then next state. So what our sequence is? 1 0 1. Okay, if it is 1, here it is detected. If it is 1, then it will be repeated to S0 state. S0 state. Else means it is 0, then our next state will be S2. Okay, some spelling mistake is there, I will correct it. Next state. Okay, here y is equal to again 0, because for now we haven't detected our sequence. So here end is missing and here end we need. Okay, now last state is our S2, and in S2 state begin end. Okay, if x, so remember our sequence S0 1 0 is detected and 1 is there, then our sequence is detected. So next state is our S2 only, it will remain in S2 state because our sequence is detected, and y is equal to 1. Now here we write begin and for if else our next state will be S0. So after this will be our y is equal to 0, because it is 1 before, then end, and this end is end for else, this end is end for our S2, and then we will write our default in case, then begin. Our next state by default will be S0, and y is by default 0, and end. Then another, this end is for end case, then next end is this for always block, and this end is for end module.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So module, FSM, TV, and our range here will be x and reset, and our clock. Wire will be our y, and instantiation of FSM F1, and we are writing what x, y, reset, and clock. Okay, positional mapping, instantiation Okay, positional instruction, positional nothing, whatever you want to say. Now initial begin. First we will give a reset. Okay, so reset equal to 1. After #5 you can say 5 unit delay, we will give x is equal to 1. After #5 we will give x is equal to 0, and #5 after we are giving 1. Okay, so after this thing we should be able to see one sequence, okay, and end. So you can give multiple inputs, and as always we are writing, and here our writing $finish. You can write anywhere. So after this 15 unit delay, $finish will be there. Lastly we will use initial begin end and $monitor for our y. You can say whatever, whenever you want to see y has our %d and you need x our input, and then these things are I think enough, and you can write y comma x and you can see monitor this, and never forget and module. So we will meet next video for SystemVerilog course after this one, but before that we will see our code once. So this is our code. So all the things I have already told you, all the things are same here as well. Okay, and end case, and lastly our test bench will be there. Okay, delay and these inputs and similar thing which I have already written in that theory. Now here is our output, and you can see 0001. So 101 is detected, the output is 1. Then again 101 detected, then output is 1.
Please Lord give me a sign, a sign.